Hello and welcome everyone. So I'll be trying to explain a very fascinating problem that I have encountered on Code Forces. Really excited to share the solution with you guys. The problem name is t-pasting. Basically, you're going to be given two arrays here, and array A and array B of length n. The array A will denote um, n types of t's and the number of milliliters of each and every type of tea that are available right now by the manufacturer, or the manufacturer prepared about AI milliliters of the sort of tea. And the second array that you're going to be given is the array B, and that array B will denote the testers, or you can say we've got n testers, but the values inside the array B will denote that each and every tester's maximum consumable level of T would be. So if we say that the array B of 986, this does mean that we have three testers for testing the T. The first tester can consume at most 9 milliliters of the T. Second would consume at most 8 milliliters, and the third would consume at most 6 milliliters of the tea. And finally, what you have to do is you have to output how many milliliters of tea each of those testers are actually gonna consume. But you see, the process of having the tea will be a little bit different than usual. What is the process? How the process is going to work out? The process is going to work out. Let's say this is my array. Okay, let's say this is my array A and this is my array B. Or should I say array B, the number of testers and the number of uh, T types that I have. Here, the position of the value definitely matters. As you can see, we've got 0, 1, 2, 3, 4. We can assume that the testers are in line like that, and after in the first iteration, each and every tester will consume as much as milliliters as possible uh, with their corresponding T types. So initially, the number 0 tester will consume the number of 0 type of T, number of 1 will consume the number of 1, number of 2 of consume the number of 2 types of T. I hope you get that what I'm trying to say here. But after the second iteration, what can happen is and now also one thing to note is that each and every value of B is that uh, the member or the tester can maximum consume that amount of that particular amount of T each and every time. So after after the first iteration, this let's say for this tester will move to here, and he's going to try to test this type of T, how much it's left. That's going to be an issue, but we'll get to that. But first of all, the thing that's going to happen, and after every iteration, they are going to switch like that. So number three number tester is going to move to 2, 4 is going to move to 3 and try to test that T2. 5 is going to move to 4, 1 is going to move to 0, so on and so forth. And after this iteration, what's going to happen is that 2 will move to 0 because in the second iteration 2 was moving to here. So after that, in the third iteration 2 would move to 3. I hope you get what I'm trying to say. But you see, after zero number, after consuming the 0 number of milliliters of the tea, uh, the the performance of each and every tester ends, and you're going to have to output each and every tester's consumable milliliters of the tea. So that's like the bottom line here. Now, in order to solve this problem, we need two types of techniques. First of all, we need to apply two types of techniques. First of all, the scan line algorithm, we need that. I have a video that I have created on scanline algorithm. You can check on it. I'll give the link in the description. And also we need binary search to solve this problem. Okay. And now the question is, how are we literally going to solve this problem? Our n is quite big, 10 to the power 5. We cannot just jump right into solve an n squared solution here. And yeah, so first of all, we need to think about this problem in an opposite way. Instead of thinking about how much each tester is gonna try to have, as you can see, let's say tester number 3 is gonna always have the ability to taste these sort of type of tea. But we're not going to think about it like that. We are going to instead think about how much each and every type of tea is going to get consumed. That's how we're going to think. And that's exactly why I have written this equation right here. Let me draw again. It's actually getting quite messy around here. Okay, now, yeah. What did I actually wrote down? AI minus BI. Okay, this is getting really messy around here. Oh my god. Okay, yeah. So yeah, about the equation that we wrote before, AI minus BI plus 1 minus BI plus 2, and so on and so forth. What is this like? Basically, this is like what? Ith type of, so we're going to deal with each type of t's consumable level when they're going to actually get emptied by the testers. We're going to try to find out that index. So for instead of going in terms of the testers, we're going to go with the tasting type. We're going to work with that. So if I have like this array of A, let's say I'm dealing with this one, I will only instead of thinking about it like recently that I've talked just recently that I've talked about, I will think about it like that. Okay, how much this portion, this value, let's say V, is going to get consumed by this tester or this tester or uh, this tester or this tester or this tester or this one. So the rightmost one we're going to try to check, but not the leftmost one, because he's not going to face that. That tester is definitely not going to face this type of you know uh, uh, the taster that is currently here is definitely not going to be able to taste the previous type of uh, or should I say, the type of test that's going to be actually afterwards to that index. So I hope you get my point. So we're only dealing with, for ith index, we're only dealing with for the ith index type of t, we're only dealing with from I till n, how many of those testers are actually going to consume. That's what we're dealing with. Now, how are we actually going to find out this part efficiently? What is the right I that's going to give us? Okay, we have a bunch of array values, but I know that at this index, our ith type of t actually completely becomes empty. How are we going to actually find out about that? We need prefix sum, and we also need binary search. So we can easily just do a solve function to, uh, do the binary search to find out the um, absolute, or should I say lower bound, maybe lower bound index. That's going to try to find out, okay, this is the entry point, this is the pivotal point where this is the pivotal point where actually uh, our ith type of t's you know consumable level actually gets emptied by all till emptied by the number of by some number of um, tasters. And so we're going to find out that using binary search. And after finding out the binary search, what we're going to do is we're going to then after that we're going to use the scanline algorithm, as we cannot constantly update every index. Okay, you have consumed this amount, this taster has actually consumed this amount, this taster has consumed this amount, this taster has consumed this amount. We're not allowed to do that. If we use it somehow after, let's say, getting that, okay, till this index I know these were the tasters that were trying to consume that ith, so I will say that, okay, up until then I will add their values. But no, we're not going to do that. We need a we cannot just constantly right away implement that. If we do that, we're going to get time limit exceeded. Instead, what we can do is, let's say these were the values responsible for consuming the um, ith, and so what we're going to do is we're going to add 1 here and add -1 here, which is basically the scanline version. I'll give the link in the description. You'll understand it more, because after we do all the binary search part, we're going to do a prefix again with another array that's going to give us, if I do a prefix operation here, it's going to give us 1 1 1 and 0, as you know. Then I will know that, okay, corresponding v array's value is going to get multiplied by this times, because we know that ultimately this times this value times bi has been used in order to consume uh, ith number of, type of t. And yeah, that's pretty much. And also there's a fractional part. There could be a case where you might not fully consume um, the ith type of t. um, let's say you have your entry point, let's say you can consume at most 6 milliliters of tea, but the tea type has 5 milliliters, so you cannot consume all the 6. You're going to have to take the minimum, so that would be the 5 milliliters. So you're going to have to also check one condition for here too, for this thing too. And so everything is actually implemented in the code. I will actually show you what is in the code section, and you would understand it more, I think. And take a look at this. Okay, we're taking all the values, important values here, and initializing to 0, taking AI and BI. We're taking the prefix sum, as I've told you why we're going to take the prefix sum, because we need to apply binary search. We need to do this problem efficiently. And after that, this is like for every index of ith type, we only care about from I till n plus n till the nth. We're going to apply binary search. We're going to try to find out the exact index, uh, which is the uh, we're going to try to find out the exact index, which is the entry point. And after that, here we have applied the scanline operation. This is the prefix. This is going to be the prefix version of that scanline operation. And after that, we're going to use how many times the how many times the ith taster is gonna taste that particular milliliter of tea, and we're also gonna add the fractional part that we created, and we're also gonna apply the fractional part if it requires, or if it has actually. This actually GG of I part is actually the part that I talked about here, 6 and 5 for this thing, and all the possible for all the possible members. And finally, we're gonna just output the answer.